today's agenda is or topic is comparing data engineering options on Azure. So what we have on Azure. So there are lots of options available, and obviously in this 1 hour session, there's only so much we can cover. So I'll try to give you a bigger picture, like what options are available, when to use what option, and definitely you can choose to have various architectures in place. You can mix and match some of these technologies. You don't need to use all of the options. You can choose to use one or the other and so on. Okay, so basically, today we will discuss what is BI. So just so that we know some of the core concepts of BI, and then after that we'll discuss how data engineering is different compared to the traditional BI or business intelligence process, and then we will talk about various data engineering options on Azure. And before we get started, I would like to ask you a question. So, how many of you are already using BI, business intelligence, like any tool, maybe Power BI, maybe SQL Server Analysis Services Cubes, or IBM Cognos, or any other data warehouse sort of solution? So, those who are already using it, please raise your hand. Okay, so very few of you are using some of these options, so that's good. So we will first of all quickly recap what is the traditional BI, then we'll talk about what is data engineering, how it's different compared to BI, and what are various options on Azure. So let's start off with the traditional BI, business intelligence. So BI or business intelligence is basically a process that organizations usually implement so that they can utilize their data effectively. And before I show you this diagram, so traditionally, or actually even these days as well, you can implement BI something like this. So you can have, let's say, your SQL Server based data, you can have data in Oracle, you can have Access, you can have Excel spreadsheets, CSV files, XML files can be there, and these data sources can contain some data. So you could have multiple systems, like your human resources system could be using SQL Server. Likewise, your accounting system could be using Oracle and so on. So usually when you have to make a decision, so whenever you have to make a decision, not just a simple decision, but an intelligent decision. So based on whatever data you have, you need to make an intelligent decision. You need to, first of all, consolidate data. And that's where we usually get to create a data warehouse. So data warehouse is nothing but just consolidated data. That's basically sort of the aggregation of what we have in various data sources. And definitely there are various tools available for that, like integration services is available. And you can also choose to create data warehouses that are more optimized for the analytical purpose, like optimized for the select queries and so on. So for that, you can choose to create OLAP cubes and so on. So basically, traditionally, this is all we used to do. So we mostly focused on how to create a data warehouse and then just connect to it from various reporting tools. Uh, Whereas these days, we have much more than that. So before I cover what is new in data engineering, so overall, as a BI developer, as a BI report designer, etc., we usually have some data available to us in a data warehouse. So a data warehouse is basically the consolidated data. And before we come to this point, usually we have to implement an ETL pipeline, extract data from various data sources, modify it, add new columns, remove columns, change data types, uh, convert text to lowercase, uppercase, etc. You can perform various transformations. And then you can load data into your data warehouse. So that's what we usually we focused on back in the day, especially when we used to have simple scenarios. Simple scenarios usually means maybe around 1 GB of data. That's usually the common thing for the traditional BI sort of data warehouses. Whereas these days, we have gigantic data available. And before I talk about some more details, so these days, as a modern data engineer role, we need to implement our data pipelines in one of these two ways, or actually both the ways. So rather than just using the traditional ETL pipeline, extract, transform, and then load your data into your data warehouse, that is also known as the batch operation. Uh, these days, you can also utilize the stream concept, the real-time processing of data as well. Then batch processing, usually there will be some scheduled time interval, like you'll say that every, let's say, 20 minutes, 30 minutes, every few hours at midnight, once a week, you want to perform the ETL operation. So your data warehouse should contain the up-to-date data every few hours, minutes, or whatever duration you want to configure. Whereas when you want to use the real time or the stream option, it means that usually in less than a second, the new data should be available to you. So you basically want to stream data. Like in the real world scenario, usually we will end up having, let's say, Power BI based dashboards, or you can use any other reporting technology as well. So your dashboards will basically show you the up-to-date data pretty much every second. They will get dynamically refreshed. So that's basically the streaming concept. So basically, data pipelines is being able to use both the ETL pipeline, that is also known as batch, and also be able to use the stream concept or the real-time processing concept as well. So basically, as data engineers, it's both these pipelines, not just the traditional ETL pipeline. Plus, as a data engineer, we usually also have to deal with the three V's: variety of data, volume, and velocity. So variety usually means you might have data available in various data sources, such as Excel. You might have data in CSV files. You can have data in a technical file format called Parquet. That is basically a columnar file format that optimizes the performance a lot. Plus, it can be very huge in size as well, like several gigabytes or more than that. In fact, overall, you can span multiple petabyte worth of sort of storage if you want. So you can basically have variety of data. You can have SQL Server, Oracle as well, and so on. And volume means big data, gigantic data. So literally petabyte of data can be there. So even if you have smaller data sets, like just a few hundred gigabyte worth of data, even in that case, you're basically able to use the data engineering concepts. So you can have terabyte worth of data or petabyte. So it can be as small or as huge as you want it to be. And velocity, so performance, you need to process data pretty much in real time, like I mentioned, the streaming option. So basically, data engineers, they usually have to be aware of various data storage options so that they can suggest when to use what option. So based on variety, based on volume, and based on velocity, you have to use the right set of tools and techniques uh, so that when you make a decision, it should be based on the right data, plus it should be processed as fast as possible. So like I mentioned, variety is basically being able to use different type of data that can be structured. The structured usually means you will have data in SQL Server sort of format or table format, or you can call it relational databases. You can have Azure SQL, you can have SQL Server or Oracle, CSV, and so on. And in fact, you can also use some more file formats, like I briefly mentioned, Parquet. It's a columnar styled file or database where each file can contain data in a highly compressed and in a very efficient manner, so you can retrieve data in a very, very fast manner. So basically, rather than using CSVs, you can choose to use this more modern file format called Parquet. So basically, as data engineers, we need to know what data sources are available and when to use what data source. So what's your goal? Performance, variety, volume, velocity. So based on that, you have to suggest the right data source. And variety-wise, like I mentioned, it can be your SQL Server, it can be Oracle, it can be pretty much any type of data. It can be XML, JSON, Excel spreadsheets. You can even have PDF files where you can have tables. You can have audio, video files. These are mostly utilized when we have to utilize natural language processing and various cognitive services with machine learning and artificial intelligence to process audio and video files. Uh, and you can also use NoSQL databases as well. So you can store data in sort of a document format, like a JSON format. So it can be basically a key value store, or it can be a document database such as JSON documents. It can be a graph-based database where you want to store nodes and vertices. So typically for this purpose, we end up using something called Gremlin. So think of, let's say, Google Maps. So Google Maps doesn't store data in a relational table format. So Google Maps stores it in a graph format. Facebook, who knows who, that sort of data is also stored in a sort of a graph database format, not in a typical relational database table sort of format. They can basically have different types of data formats. So basically, as a data engineer, we should be aware of these uh, storage techniques that I'll cover in just a bit, and when to use what technique. And whatever we set up as a data engineer will be consumed by a report developer or a report designer, or it can also be used by data scientists. So a data engineer will make raw data highly usable that can be used by data scientists and also by data analysts. So a data analyst is usually a person who uses reporting tools like Tableau, Power BI desktop, SQL Server reporting services, whereas a data scientist is someone who uses some more technical options, like they will end up writing code in Python and Scala and R scripting languages, so they can implement or perform machine learning, etc., and potentially AI, artificial intelligence as well for pattern matching and so on. But as a data engineer, you need to first of all set up your data sources. So your overall architecture should be set up. So in a nutshell, a report designer or an analyst, or even let's say a data scientist, rather than connecting to 10,000 different data sources directly, we should set up sort of a data warehouse, a common data source that should eventually connect to other data sources. So data analysts, data scientists, they need to connect to some common data source. That's basically the overall goal. And as a data engineer, we need to know what are the various options and when to use what option. And that's what we will touch on in this very short session. So this by itself is a very huge uh, uh, 4 to 5 day course actually, but here in just an hour or so, we have to cover quite a few options. So basically on Azure, as a data engineer, we should be aware of what is Azure Storage, Data Lake Storage or ADLS, Azure Databricks, CosmosDB, Azure SQL Database, Azure SQL Data Warehouse, or that is actually also known as Synapse these days. So Azure Synapse Analytics is basically the new name for Azure SQL Data Warehouse. Event Hub, that is somewhat similar to using Apache Kafka for the streaming purpose. And there's also something in Azure that's called Azure Stream Analytics as well. So we have so many options. When to use what option? What's the right option for us? It depends on your business requirements. So let's have a quick understanding of some of these options. So let's start off with Azure Storage. So say that as a report analyst, or maybe even as a data scientist, you want to use some reporting tool. So say as a data analyst, we are for now going to use Tableau or Power BI desktop. So if you want to query, let's say a CSV file or an Excel spreadsheet, then in that case, where exactly these files should be stored? So although you can choose to store these files on your local machine or in some shared folder, but we want to gain performance. We are talking about big data, variety, volume, and velocity. So these data sources could be huge, gigantic, several gigabytes or several hundred gigabytes in size. Plus, we want to make sure that we load data or analyze data as fast as possible. So we want to gain performance. So that's why On Azure, you can choose to use something called Azure Storage. So an Azure Storage service allows us to store raw data such as CSV files, Excel spreadsheets, XML files. You can store Parquet files, Avro files can be stored, and so on. So basically these are various file formats you can choose to use. There are actually more options available as well, but these are the more commonly used file formats. And when you use Azure Storage, you can actually also choose to use it in other ways as well. For now, let's not make it very sort of complex or go into too much depth of it. But in general, you can also choose to utilize NoSQL, not only structured query language-based approach as well, especially when you use Azure Storage containers. We can ignore the rest of the options for now. So basically, Azure Storage is what you can choose to use when you have to store gigantic CSV files, Excel spreadsheets that you want to analyze as a data analyst or as a data scientist. And to improve performance even further, when you set up this Azure Storage on Azure, you'll want to enable an option called Azure Data Lake Storage. Then Azure Data Lake Storage is basically just a simple checkbox. So when you set up an Azure Storage account, you just switch to advanced, and there you just see this Data Lake Storage Gen 2 option. You just have to enable it. And this essentially enables this Data Lake Storage technology that is also known as hierarchical namespace. So basically, it improves performance. If you have heard of Apache Hadoop, that is basically a distributed file system sort of concept where you can have parallel processing of your data going on in parallel. So the similar concept is provided by Azure Data Lake Storage on Azure. So this way, if you have a CSV file or Excel spreadsheet is there, and when you load it, it will be done in parallel. So basically, the backend, the storage backend, is backed up by top-notch infrastructure, and it basically provides us with multiple nodes that run in parallel. So it improves the performance of loading of your files such as CSV, Excel spreadsheets, and so on. In short, we can use this as a data engineer to improve performance of data analytics sort of operations when we upload data or process data from a reporting tool and so on. And you can also use Azure SQL database on Azure to store just the regular relational data. So if you are coming from the traditional database back, let's say administrator, developer sort of background, you can choose to use this Azure SQL database on Azure. So it's basically a relational data store, and it's transactional in nature. OLTP workloads are performed. So say you already have some existing database in your on-prem environment, you want to set it up on Azure, you can choose to use the Azure SQL option on Azure. So CSV files, ideally, they should be stored in Azure Data Lake Storage to improve performance. And SQL Server database can be stored or set up in an Azure SQL sort of service on Azure. And then you can use Power BI or Tableau sort of tools to connect to whatever data source like SQL Server or CSV if you want. So usually, even as a traditional BI, business intelligence developer, administrator, usually we just deal with these two main options, like a SQL Server, or you might have Oracle and you have CSV files. So usually we just deal with these sort of data sources. But as a data engineer on Azure, we have a lot more options. And before I cover some more options, so a quick note regarding Azure SQL. So when you set it up, it does give you several options, like how exactly you want to set it up. So you can choose to use the easiest option, that is known as single database. So single database usually means it will be used as sort of a platform as a service. It will be a managed database managed by Microsoft. So there will be no infrastructure to worry about. You do not need to install SQL Server as a DB at all. You do not even need to manage it. You do not need to take any backup of your SQL Server itself. Database, sure, you can take the backup of database itself, but the SQL Server instance, that is not your concern if you use this single database option. And if you say that, no, I want to take charge of the database server instance, I want to make sure that I can shut down the instance, maintain the instance, perform upgrades, etc. manually, like I do in the on-prem environment, you can choose to set it up in a SQL virtual machine, and then you can do whatever you want. Install whatever version of SQL Server you want and so on. And we do have some more in-between type of options. Uh, these are all very in-depth sort of options. For now, know that you can choose to have the managed option where Microsoft will manage the database instance for you. You just need to focus on the database itself. So for example, in my case, I actually have my SQL Server database setup. So without worrying about any uh, SQL Server instance, I can just focus on the database itself. So I have this sample AdventureWorks database set up here, and you can just obtain the connection string from here and just start using it. I can just copy the connection string. This is not the actual connection string. The actual connection string, you can obtain it by switching to this particular screen, and you can just connect to it and start using it. So basically, you do not have to worry about installing the database server itself at all. So on Azure, this can be a very easy way of starting using relational database such as SQL Server. And similar options are available for PostgreSQL, MySQL, and also for Oracle as well. Now we can get into the real stuff that is done by data engineers on, let's say, Azure. The real stuff as in what's different compared to what we already use in the on-prem environment. So typically in the on-prem environment, we usually have CSV files, Oracle, SQL Server. Now on Azure, you can use Azure CosmosDB as well. So Azure CosmosDB is basically a NoSQL database. It is a NoSQL database where you get to store documents, not PDF documents, but JSON documents. So each row is stored as a JSON document that can be structured. You can have multiple columns set up. Overall, there's no schema. It's sort of a dynamic schema. So whatever your JSON document says, that will be the structure or the schema of that particular database table. And when do we use this Cosmos DB? Why do we have to use it? Why not just use Azure SQL database or Oracle? So when you use Cosmos DB, that I've listed here as a NoSQL option. So if you have this NoSQL database and you connect to it from Power BI or Tableau, etc., why should we do that? Why do we even have to host it or store it in a NoSQL Cosmos DB database? Performance. So you want to gain performance basically. So you still want to be able to perform read plus write operations. So you want to be able to use all your regular queries such as insert, update, delete, uh, and obviously select as well. So insert, delete, update, select. You want to perform all the regular CRUD operations, create, retrieve, update, and delete. And performance-wise, exactly what level of performance we're looking at, you can easily achieve 100 million operations per second worth of performance or level of performance. And you can even exceed this performance level as well. You do have to pay accordingly, but it's possible to have literally millions of users connected at the same time. So think of, let's say, Facebook, Twitter, Gmail, etc. So millions of users are connected at the same time, and they perform various operations pretty much every second. So performance is what you want to gain. So rather than using your regular SQL Server database or Oracle, now you'll end up using this Cosmos DB with something that is known as Core SQL API that allows us to use the JSON documents or query them by writing the regular select statement, insert, update statements can be used as well. So overall, select statement will be identical. There'll be no difference whatsoever. There are very minor differences, but overall, inner join, left join, they do work. Uh, and you can also choose to say that we have some other NoSQL options, like you can use MongoDB. If you already have it in your on-prem environment, you're used to it. You can choose to use it on Azure as well. Cassandra is a columnar database. That's also a NoSQL database. It stores data column by column, usually. You can also use a Graph API, that is also known as Gremlin. Basically, you can store data in the form of nodes or graphs, basically. So CosmosDB, as a data engineer, we should use it when you want to have high throughput and low latency. So you literally want to have tens of millions of operations or requests per second. And query response time should be very um, less as well. Like we cannot have network latency involved. So that's very Cosmos DB will be a recommended solution. Plus, it's always available. 99.999% of the time, it's always available. So downtime will be won't be there. Like there's a very minor chance, but you don't really lose data because you have geographically scattered copies of it. So it's a global distribution of structured as well as unstructured data. So you usually never lose any data at all. In the worst case scenario, your application will just notice some slowdown just for 2 to 3 seconds, and that's the worst uh, case scenario basically. So low network latency, that's what you want to have, plus you want to achieve high concurrency as well. The throughput is your main goal basically, and you want to have literally millions and millions of users connected at the same time. If you don't see that level of performance required, you can still use it because it's not that expensive for smaller data sets. Otherwise, you can still choose to use the regular SQL, Azure SQL option on Azure if you want. Then now we get into some tricky options. Databricks, Synapse, Event Hubs, and so on. And Databricks wise, before I cover this thing, let me actually just quickly start up my cluster. So it will take a few seconds, and while it's doing that, I'll be able to go over the slide. So while it's starting up the cluster, is anyone using Databricks or Synapse by any chance? If yes, please raise your hand. Okay, apparently no. So let's talk about these options. Um, so these are slightly advanced options. Like not everyone will have this requirement. Those who have this requirement, definitely you will benefit a lot from Azure Databricks or Azure Synapse. Otherwise, typically most data analysts, they are usually okay with SQL Server, Oracle, CSV files. But as a data engineer, we should be aware of all these options and then decide when to use what option, what options we should combine, and so on. So both Databricks and Synapse, overall, even before I go through some of these bullets, overall, they both can act as data warehouses. So these are the modern data warehouses. So compared to what we usually have in our on-premises environment, like if you're using the Microsoft tools, let's say stack, you can use SQL Server analysis services or the cubes basically. You can also use cubes in a different format that is basically known as tabular data model, TDM. So SSIS analysis services lets us create the multi-dimensional data warehouses or the tabular data model based data warehouses. That's the on-prem setup usually. And usually it's okay for very smaller small data sets, like you just have maybe a few gigabytes worth of data, not more than that. But if you have gigantic data, big data, volume, velocity, and variety. That's where you need to use some more advanced solution, such as Databricks or Synapse, or you can actually use a combination of both as well. So what exactly is Databricks and Synapse? Let's talk about Databricks first. So Databricks um, internally, or in a nutshell, it's basically based on an open source project called Apache Spark. So Apache Spark is basically a technology that can be used in your on-premises environment. And what exactly is Apache Spark? So it's basically a cluster that can contain multiple nodes, where each node is a machine. It can be a physical machine, it can be a virtual machine, it can be running in your on-prem environment, or these can also be on cloud as well. An Apache Spark cluster will be able to connect to any file system like CSV, or even to your relational databases such as SQL Server. And the point is that we want to be able to query data. So whatever your reporting tool is, such as Power BI or Tableau, you can use any of these tools, and you'll be able to query these underlying data sources like CSV, SQL Server, without going to each data source one at a time. So rather than asking data analysts or data scientists to memorize or to make a note of various data sources, we just tell them that no, we have a central sort of setup. You just have to be aware of a single location or sort of a single data source that will eventually connect to other data sources. So you keep data in the underlying data sources. You keep data in a CSV file. You keep data in your SQL Server database. And this Apache Spark based cluster will be able to fetch data. And the reporting tool that we have here on this side will be able to get that data. So as opposed to using the traditional approach where you fetch data into your uh, data warehouse by using the ETL operation. So rather than loading data into the data warehouse, you're saying that no, we have gigantic data. We cannot really load all this data into a single database, because that will either be too time consuming, because we have gigantic data, we have literally several terabyte or petabyte of data. Uh, Usually, this is the main reason why we usually don't bring data into our database. So basically, Apache Spark is the underlying technology that is used by something called Databricks. Where is the slide deck for that? So basically, Databricks is just a wrapper. It's a framework on top of this Apache Spark technology. So Apache Spark, usually when you have to set it up manually in your on-prem environment, it can be a pain in the neck. Whereas Databricks is a cloud-specific technology. You can choose to use Databricks just by going to the official databricks.com website, or you can say that no, you already have an Azure subscription, so you want to use Databricks on Azure. So Databricks, in just a matter of few clicks, you'll be able to set up the entire Apache Spark-based cluster in just a matter of few minutes. So you just click a few options, you specify what hardware configuration you want to have, and in just a few minutes, you will have a multi-node Apache Spark-based cluster set up for you. And I already have a cluster set up on in my case. So if I just quickly show you this part here, so I have this cluster setup. I'm using the bare minimum resources right now because you do have more fancier configurations available as well. But since I don't want to incur too much charges, so that's why I'm using this minimum configuration for now with 14 GB RAM, 4 cores, and it's a single node currently. But you can choose to have a multi-node setup. You can have as many nodes as you want. You do have to pay accordingly. So usually the more nodes you create, the more data you can process in parallel in a super fast manner. So again, we are thinking in terms of several hundred gigabytes or several terabytes or even petabyte of data. Like banks, financial companies usually have gigantic data. Likewise, if let's say if you think in terms of let's say Google and various other companies like Twitter, etc., they usually also have to analyze their data at a super fast pace. So basically, I have a cluster set up, and it's usually done in just a matter of few clicks and a few minutes. So it's very easy to set up on cloud. And it basically lets us do both batch as well as streaming based uh, or implement these type of pipelines. So you can say that you want to load data every few minutes, hours, um, or you can say that you want to read data in a sort of a real-time streaming sort of format. And overall, it basically lets you write code, and you get to maintain it in the form of notebooks. They're also known as Jupyter notebooks. So Jupyter is basically an open source technology that you can use in your on-prem environment as well, and it lets you write code in Python, Scala, R scripting language, and also in SQL as well. So if I show you part of the stuff, or before that, let me actually show you this slide here. So basically, Databricks will act as a data warehouse that can be used both by data analysts and also by data scientists. But it has to be set up by data engineers. So a data engineer will have to create a workspace. And in the workspace, we will have to write a bit of code in Python, R scripting language, or Scala, or SQL, and so on. And you'll be able to consume data from your existing data sources. It can be your Excel CSV sort of file. It can be Azure Data Lake storage. It can be Synapse. It can be Kafka for real-time streaming. It can be your Apache Hadoop cluster-based data or HDFS file system as well, and so on. And the main benefit will be, in addition to acting as a central data warehouse, so basically it will be a single point of contact as far as the data analysts and data engineers, or sorry, data scientists are concerned. So we no longer have to ask them to make a note of every individual data source. Now they just have to be aware of a single data warehouse or a single data source. And this is where we have some code that will be capable of connecting to various data sources. And then whenever this particular tool used by data analysts or data scientists requests for data, Databricks will be responsible for fetching the data for us. So keeping this in mind, let's see this thing a bit practically as well. So basically, I already have a workspace where you can set up multiple notebooks, where each notebook is basically a bunch of scripts. So in my case, I already have Python-based scripts. You can actually also choose to use other languages like Scala. You can use SQL. You can also write code in the R scripting language as well. So here I currently have some code that will be capable of connecting to a CSV file. It's my sample COVID-19 CSV file. And you do have to write a bit of code in Python here. So we are using PySpark, Python that runs on this Apache Spark-based cluster as part of this Databricks technology. And I'm reading the contents of the file basically into something that is known as a data frame. So think of data frame as sort of a table. So once I've loaded data into my data frame, you can name the object whatever you want. So I actually already have this script already executed. So when you run the script, it will basically use that Apache Spark-based cluster. So Databricks will use that Apache Spark cluster to run the query. And usually you'll see major performance benefits when you have gigantic data. And you can even see some outputs here as well. That's not the main goal of seeing the output here. You can actually use Power BI, Tableau sort of technologies to query the data. So you can basically load data into a data frame. You can also choose to create a view out of it, just like we create views in SQL Server and Oracle. And then you can use the regular SQL queries. Select start from whatever the view name is. And in fact, you can also see some visualizations as well. So here I'm showing data in this bar chart format. You can also choose to see it in map format as well, and so on. So we do have some visualization support available here as well that can be utilized both by analysts and by, or mostly by data scientists, because Python is something that not every data analyst will want to learn. But you can learn SQL queries and you can write code in SQL queries. But still, some of the code will have to be done or written by data engineers, so that later on data analysts can just query it. Or if you don't want to use this stuff at all, just let the data engineer set this up for you. And then as a data analyst, you can use Power BI. You can use even, let's say, Tableau to connect to this Databricks and query it at a super fast pace. You can also save whatever we have here, the CSV file, as a table. So we are writing a table in this Parquet format. It's a technical file format that uses the columnar storage approach. And I actually have the table set up here. So basically, this is the table. And we don't have time, otherwise I would have shown you how to connect to it from Power BI desktop as well. So basically, usually in Power BI desktop, I'll just briefly point it out. Hopefully I have Power BI desktop installed here, since it's not the main scope, but I'll just quickly point it out here. So usually you can use tools such as Tableau, Power BI, desktop, and you can point to this Databricks based storage. So you go to get data, and rather than using your regular data sources such as SQL Server, CSV file, now you're saying that we have big data, gigantic data. We need to gain performance. We want to potentially have real-time streaming of data that should refresh our dashboards pretty much in real time. So for that purpose, you can basically use this Databricks. So we have Azure Databricks if you want to use Azure flavor of Databricks. Otherwise, we have the regular official Databricks uh, option is available as well. So usually, if you're using Azure, prefer using Azure Databricks. Otherwise, if you're using the non-Azure edition of Databricks, you can use Databricks option. So basically, this will ask you to specify your connection string, where your host, what's the host name, and you can specify what table you want to load from that particular Databricks, and it will be done in a very fast manner. So overall, Databricks is basically going to act as a data warehouse. And in more advanced cases, data scientists can utilize machine learning features as well. Pattern matching, pattern detection. You can use various algorithms like association, clustering, classification algorithms that they use, and so on. So you can basically come up with various sort of potential solutions or patterns. So for example, in terms of COVID-19, you can say that if this is the current data and this is your sample input training data set, then what are the chances that for the entire country or for the entire world, this particular data will be true? Or what will be the chances that, let's say, the COVID-19 virus will spread out, etc., and so on. So basically, sky's the limit. You can use it in pretty much any type of scenario, like in sales sort of scenario to predict sales, etc., and so on. So basically, Databricks, it's a very useful tool that can be quite advanced. And like I mentioned, if you want to keep it simple, as a data analyst, you just use Power BI and you just connect to it and start creating your reports. But as a data scientist, you can use much more than that. So usually for this purpose, we get to use more libraries in Python. Like we get to use TensorFlow. I actually might already have it summarized here. So you can use Scikit, you can use PyTorch, TensorFlow, Keras, MLflow, machine learning flow. So there are various libraries you can choose to use. So basically, overall, it's a data warehouse where you don't need to load data into your Databricks environment. You can choose to keep it in your underlying data source and just query it in sort of real-time manner. Because in gigantic databases, you cannot really perform the ETL operation. You cannot load gigabytes and gigabytes of data every few seconds or minutes or hours or days. It's not always possible because of the volume that we have for the data. So you'll want to keep it in your external data source. Uh, so basically, overall, it's a data warehouse that supports machine learning sort of capabilities. There is a slide deck. Okay, likewise, we have something called Azure Synapse as well. Synapse is actually a competitor solution to Databricks. Overall, they are quite identical. There are lots of similarities. So if I show you this diagram again, so both Synapse and Databricks can act as data warehouses. They will act as single point of contact that can connect to various other data sources. And again, you can use Power BI Desktop or Tableau, etc. So here, if I show you briefly, I can go to Power BI Desktop, and we can see that we have a Synapse option available here. So just like we can connect to Databricks, likewise we can connect to Synapse as well. So Azure Synapse Analytics. Again, it will ask you to specify the connection string, like where exactly your Synapse is set up, what database you want to connect to that's available on Synapse, and so on. So if they are both identical, what's the point? When to use what? So overall, like I mentioned, there are lots of similarities. And before I show you a quick demo, let me just summarize the pros and cons. Synapse is useful when you want to use an easier data pipeline approach. You want to create your data pipelines, you want to perform transformations, you want to add columns, remove columns, change data types, etc., and so on. But you want to keep things simple, because in case of Databricks, you need to know Python. You need to know some programming language like Scala or R or even SQL. Usually we use Python, that's more popular. Uh, so you need to know some scripting language. Whereas in case of Synapse, it's actually possible not to use any scripting language like Python, and just use SQL queries, and also use the GUI-based support. You can use the graphical user interface support to create your data pipelines, to perform transformations. So basically, it offers the no-code approach to creating your data pipelines. This is where it really shines. It makes things very easy. So overall, it still acts as a data warehouse, but rather than writing everything in a very technical Python sort of format, you can choose to do things in a graphical manner as well. So for example, if I go to my Azure Synapse Studio, uh, that back in the day used to be called Azure SQL Data Warehouse. Now it's called Azure Synapse. So here you'll be able to do several things. So for example, here I have a database setup that's pointing to an external CSV file. It's COVID-19. So again, you can choose to load data physically into your Synapse database, into your data warehouse, or you can say that no, the files will be gigantic. I do not want to load data. I want to keep it in my original data source and query it in real time. So that's where you can use the external table option. Plus, it lets you write code in SQL format. So for example, if I just use this one, so there are lots of similarities, like it's very much the same SQL syntax we use in the on-prem environment, but there are some differences as well. So usually when you run your query, this is basically querying the external CSV file. It's not a, a physical table in my database, it's an external CSV file. And I'm able to use the same SQL syntax here to query my CSV file. Likewise, you can have other external data sources. Like I showed you here, you can have an external SQL Server database, table, Oracle, CSV file. You can have NoSQL databases as well, and so on. So basically, overall, it lets you add various data sources. You can even connect to Amazon hosted services as well, like RDS for Oracle, for SQL Server, and so on. Plus, I might already have some sample scripts here. So you can write code mostly in SQL format to create your data sources, your external data sources that will be connected or treated as tables in your Synapse data warehouse. Plus, it lets you create workflows as well, data pipelines basically in a graphical manner. So you can basically use the graphical features here. I won't bother creating a complete example here, but you can see that I can add my source database or any other source such as a CSV file, and I can choose to add more columns to it. I can add a derived column. I can choose to remove some of the columns. I can perform aggregations without writing any code here whatsoever. So basically, the graphical support for designing the data pipelines is available here. And if you want to make it more advanced, very much like Databricks, where you can write code in Python or other languages, in that case, you can choose to configure your Synapse with Apache Spark pool. You can add a pool here, so you can write your code in Python and other languages like Scala, etc., and so on. You can basically see that we have by default SQL support, but you can use notebooks here, and then you can use pretty much any language here. So for example, you can have, I don't have any Spark pool configured here, but once it's configured, you'll be able to use Python, R scripting language sort of options as well and so on. So basically, Synapse is very much the same as Databricks conceptually. It acts as a data warehouse, but it provides you with some ease of use. You can choose to use the graphical options, not write everything in a very complex manner. But if you want to use Python, go ahead, use Apache Spark pool with Synapse. And overall, if we have to pick one or the other, these are the two lines that we can focus on. So Synapse is easier overall when it comes to creating pipelines. Databricks is better when it comes to stronger machine learning capabilities because it has out of the box support for, or you can configure it to support, let's say, TensorFlow, etc. So there are various options available. And although you can do that with Synapse as well, but usually that's more pain in the neck compared to what that's usually available with Databricks. So for better machine learning, use Databricks. For ease of use, when it comes to designing your pipelines, prefer using Synapse. And actually, some companies, they combine both of these options. So for example, they can say that Databricks will be used as the machine learning component, and we will still have Synapse in place as well that can act as a central data warehouse. And now you can have other data sources like CSV, Excel, SQL Server sort of data sources can be there, and so on. So Synapse can be used as your uh, data warehouse to make things easier when it comes to connecting to various data sources. And then for machine learning purpose, you can choose to involve Databricks that can connect to Synapse. So basically, there are various topologies or architectures that are possible here. Otherwise, to keep it simple, in the beginning, either use Databricks or Synapse. For ease of use Synapse. For more advanced features like machine learning, use Databricks. But overall, they both act as data warehouses, so you can connect to various data sources. Um, and you can also use something called Azure Data Factory. That's usually built in into Synapse. So if you recall, I briefly pointed out that you can choose to create a data flow or data pipeline, basically. So this graphical designer, internally, it's making use of something called Azure Data Factory. The Data Factory is about implementing the ETL, extract, transform, load sort of pipeline. So you want to load data from various data sources, potentially modify them, transform them, and then potentially load it as well. And then eventually it can be consumed by Power BI. or Tableau sort of reporting tools. So Data Factory is basically the ETL pipeline designing part, and it's usually built in into Synapse. Then we also have something called Event Hub, and let me actually combine it with the Stream Analytics. So Event Hub and Stream Analytics can be used to utilize the real-time streaming concept by using something called Apache Kafka. Sort of cluster can be used with Event Hub. So Event Hub is basically a real-time sort of a processing engine where you can choose to send events or sort of messages, and you get to store them in something that is known as a topic, where each topic can be partitioned. So think of it as like a message queue, very much like a RabbitMQ queue, or you can also use various other options as well. So basically, any messaging system like RabbitMQ, IBM also has the message queuing system as well. So you can use it as an sort of a message storage system where you can store data in the form of messages in your topics that can be partitioned and so on. And what it has to do with data storage option, when should we use this option? So this option is mostly suitable when you want to have mostly useful when you have IoT devices, Internet of Things sort of devices. So for example, think of any vehicle. Let's say you have a Uber sort of system where Uber is going to send its location in real time. It can be any transit system as well, where we can see where exactly the buses and other vehicles are available in real time and so on. So it can be pretty much any type of IoT sort of scenario. It can be any sensor as well. It can also be an application running on your system as well if you want. So basically, you can store data here or send data in real time to this Event Hub, and it will get stored temporarily here. Usually it can be stored for up to 7 days, and eventually it has to be consumed by your application. So this is typically useful in very advanced scenarios where you do want to have the streaming support. So this can be used with, let's say, your Power BI sort of dashboards if you want to see the data in real time. Like you literally want to see your dashboard getting refreshed every, let's say, second or so with the up-to-date real-time data. But typically for that, we also involve it with something that is known as Azure Stream Analytics. So we don't have enough time here to cover this entire architecture, but overall, your Stream Analytics will be responsible for connecting to Event Hub, and it can get data from SQL Server, from any client application, from any IoT device, and then it can send data to any report like Power BI dashboard can display the data in real time and so on. So basically, it's also available as one of the options when it comes to structuring things as a data engineer. So basically, as a data engineer, we need to be aware of what data sources are available, what's the business case, when to use what data source, and so on. And I think it's time. So we do have various courses available on these topics. This is a more comprehensive sort of course, but we do have other courses available as well. Like if you want to focus on relational database management on Azure, we have this course available. If you want to migrate your existing databases to Azure, we have this course available. Otherwise, if you want to look at Azure Synapse, Azure Databricks, event hubs, streaming analytics in more detail, we have this DB203 data engineering on Azure course available. So in this 1 hour webinar, we could only do so much. We do have in-depth courses available on these technologies. Okay, so thank you very much. And again, as a reminder, the slide deck is available in the handout section of this webinar software. Plus, we'll be uploading both the slide deck as well as the recorded video of this webinar to our portal as well. So thank you very much, and it was a pleasure to be here with you for this 1 hour session.